First, let's understand what YARN is. YARN stands for Yet Another Resource Negotiator. It is a key feature of Hadoop 2.0, designed to manage resources effectively across various distributed applications. So, why do we need YARN? In a big data setting, multiple applications often need to run concurrently on the same cluster. YARN facilitates this by managing resources dynamically across the different applications, ensuring optimal utilization. Now, let's break down the architecture of YARN. It consists of three main components: the resource manager, the node manager, and the application master. Let's explore each of these in detail. The resource manager is the master daemon, responsible for overall resource management across the cluster. It manages the allocation of resources to various applications and handles job scheduling. Here's a simple representation of its responsibilities. Next, we have the node manager. This component runs on each node in the cluster and is responsible for managing the application containers. It reports the node's health and resource availability back to the resource manager. Finally, the application master is a framework-specific component that manages the lifecycle of an application. It negotiates resources with the resource manager and works with the node manager to execute and monitor tasks. To summarize, resource manager oversees the entire cluster's resources, node manager manages resources on a single node, and the application master handles the application itself. With this understanding, let's now look into how to submit a YARN application. Submitting a YARN application involves using the YARN command followed by the application type and required options. Let's see how to submit a MapReduce application as an example. In this command, we specify the jar file containing our application, the main class to execute, and any configuration options necessary for the job. It also includes the input and output paths for the MapReduce job. Once the application is submitted, the resource manager will allocate the necessary resources for it, with the application master taking care of executing the tasks and monitoring their progress. Now, let's discuss the resource configuration in YARN. YARN allows us to set memory and CPU configuration for each application. This ensures that applications run efficiently without competing for resources. These configurations specify the maximum amount of memory and virtual cores that a single application can use in the cluster. You can set these parameters in the yarn-site.xml configuration file. In addition to these configurations, YARN also provides features for setting up queues. Queues are a way to manage resource allocation to different applications, ensuring that they get the required resources in a fair manner. Here, we define a maximum capacity for the queue and the default capacity that can be granted to applications submitted to that queue. This is particularly useful in multi-tenant environments. Now let's check the cluster status and monitor applications using YARN's command line interface. The YARN application list command allows you to view all currently running applications. You can also get more information about a specific application by running. This command will output the status of the specified application, including its progress, state, and resource usage. Monitoring applications effectively can help in troubleshooting and optimizing resource allocations. Another important aspect of YARN is its ability to limit resources at the container level, ensuring that applications do not consume more than their fair share of resources. This is configured in the yarn-site.xml file as well. The above configuration specifies that each container can use up to 4,096 megabytes of memory and 4 virtual cores. This way, we can effectively manage resources and avoid resource contention among multiple applications. Once your applications are deployed, you'll want to ensure they are optimized for resource usage. YARN provides various metrics and dashboards to help you monitor resource usage and fine-tune your applications accordingly. You can access the Resource Manager web UI to view the status of all applications, nodes, and the overall utilization of resources in the cluster. This is a valuable tool for managing your Hadoop ecosystem. In conclusion, YARN is an essential component of the Hadoop ecosystem that efficiently manages resources across multiple big data applications. Understanding its architecture, configuration, and monitoring capabilities is crucial for optimizing your applications. Thank you for watching our tutorial on using Hadoop YARN for resource management. I hope you found this video informative. Don't forget to like, subscribe, and hit the notification bell for more programming tutorials.